Okay, welcome. I hope this works now. Welcome to this information session on Acoustics and Audio Technology Master's Program, which is part of the Computer Communication and Information Science Master's Program at Aalto University. So my name is Tapio Lokki. I'm professor in Acoustics and Audio Technology, doing research on acoustics and audio signal processing and all kind of things. I will talk a little bit later about that. And I'm in charge of this major in acoustics and audio technology. But we have 4 professors who are teaching and so on, but I will introduce them later on. First, some contents. So what I will describe here, some introduction to Aalto University. What is Aalto University? Then audio technology and acoustics as a subject, what you can study here and what kind of things we are doing in research. Then some study options and how to apply and so on, and in the end some career possibilities. So when you have graduated from our master's program, what kind of jobs and what kind of tasks you might have in your future career. And then, of course, we are replying to your questions. That if you have any questions, please type them in and we look at them and then we have a question and answer session in the end. So first of all, Aalto University is quite new. It's just 10 years old. It was a merge of Helsinki University of Technology, School of Business and School of Art and Design. And now this new Aalto University is really a multidisciplinary university which combines all these areas together. And we have, especially in acoustics, we have quite a lot of interaction and connections to arts, especially arts. There is also a master's program in new media and master's program in sound in new media. So we have some connections to them. They are doing more like content production, and we are doing more like technology for all kind of projects. Aalto University, all the research is let's say not divided, but it's organized in different areas, which you can see here, and then it's only these kind of global challenges that we try to solve here. Where acoustics belongs there is, I think, in this human-centered living environments and health and well-being would be probably on the outer circle where acoustics is. We are doing things on hearing research, so try to understand that how human hearing works and then how we can do better hearing aids, so this kind of things. And then that's health and well-being, and then also human-centered living environments, so what kind of room acoustics there should be, what are the optimal working and study conditions, how we should damp rooms and what kind of sound environments should be in rooms or also in outside world. Okay, Aalto University is quite big on Finnish scale, but of course on an international scale it's kind of a mid-size university. We have about 400 professors in total, 4 of them in acoustics, as I said, and the size of the personnel is a little bit less than 4,000. It's mainly PhD students, postdocs, lecturers, all HR people who are taking care of studies, also on the administration side and so on. And then we have around 12,000 applicants, and then 15% of them are starting the studies here. And about 35% of the all accepted applicants are female. This is not equally divided. Of course, there is more in business school and then in chemical engineering, then for example in computer science or electrical engineering, but we have also both male and female students in all areas. So one of our slogans is the science and art together is combined with technology and business. And then we try to use quite a lot of new teaching methods and new ways of learning, this kind of co-creative, maybe challenge-based learning, some challenges where you have to solve some challenges, and on the side of that, of course, you learn quite a lot. Okay, and our university is located in Espoo, which is really close to Helsinki. So in this, you see the Helsinki is there on the background, which is more or less an island, and we are about 10 kilometers from Helsinki, downtown Helsinki. But the campus area is really a nice area, surrounded by the sea, and there is only like 10 minutes by metro, or you can bike also in 25 minutes to downtown Helsinki. And there are student housing even on the campus side or then in Helsinki in various places. Then there is a lot of side events. These are mainly organized by students. So there is a really strong student union and a lot of different kind of activities for students. These activities which are listed here is related to entrepreneurship. There is Slush, which is probably the most known event in the end of November every year. But then these are only for the entrepreneurship. Then there is also lots of other like clubs where you can do things. You can play, if you are playing some instruments, there is a symphony orchestra, there is a brass band, and then there are all kind of hobby things. If you are playing some games or whatever you are doing, you are repairing your car, you are surfing, whatsoever, there is always a small club which collects people who have got the same kind of interests together. So there is also this kind of activities which are actually really good, because then you meet also some other students from other fields. When I was a student, I played clarinet quite a lot. I was playing in different orchestras, and that was really good because then my study friends were, of course, from acoustics, but mainly they were those players, and they were from physics department, from pulp and paper industry, from industrial management, wherever, from the construction engineering, and so on. So nowadays I know quite a lot of people on different areas, which is actually really, really good thing. And then during the studies, you also learn kind of different disciplines also, not only your own field, but also the other fields and what are the challenges there, and what kind of things people study when they try to understand, for example, that how you build a big house, for example. Okay, if we go to acoustics and audio technology major, we can say that our lab, Aalto Acoustics Lab, it's one of the leading lab in the world. I think at least in top 10, maybe even in top 5. We have quite a long tradition on 30-40 years on research and education on all fields of, not all fields of acoustics, but the fields that I'm actually introducing here. And we have really good facilities. I could actually say that they are excellent facilities. They are just renovated, which you can see there on the left side. No, it's not, sorry, it's not here. It's on the next slide, I think so. And I'll come back to these facilities later on. And then we are looking students who have a background in electrical engineering, in computer science, but then it can be also that if you have background in psychology, that's really good. Of course, you need some kind of mathematical skills, maybe a little bit of MATLAB programming we are using MATLAB quite a lot, and then some other programming skills. But psychology is really relevant because we are doing a lot of listening tests. We try to understand that how people perceive different sounds, perceive different environments, sonic environments, and these kind of things. And that's actually much related to psychology and how humans hear and behave. Yeah, on the left side you probably see where we are best well known, our lab. We have developed during 20 years 3D sound recording and rendering algorithms. There's like VBAP, vector-based amplitude panning, it's from our lab. And also directional audio coding, spatial decomposition method, these kind of methods, if you have heard any of these, they are all invented here. Then there is a long tradition of modeling of musical instruments, and now actually this has turned, it's not anymore like modeling of musical instruments, but it's also nowadays modeling of all kind of effect devices. So if you have a guitar amplifier, or you have an effect module for your guitar or bass, which used to be analog techniques, but nowadays, of course, we want to just have plugins. So what we are doing is that we try to understand how the old analog devices work, and then we are implementing them in DSP, in digital signal processing. So that's kind of modeling of musical instruments, but then also modeling of all kind of effect devices. Then we are quite famous in our research in concert hall acoustics. I think we are the leading team in the world nowadays in understanding the concert hall acoustics and what makes concert halls to be good and really good for classical music. Then on side of that, it's actually room acoustic modeling and oralization. We have developed a lot of room acoustic modeling methods and then also oralization methods. Oralization means that when we have a 3D model of a space and then we are doing the room acoustic modeling there, so how the sound propagates and how it reflects from different surfaces, then how we can oralize these, so how we can listen these models. It's the same than visualization is in computer graphics, that if you have a 3D model, then you want to render some images. But here we just have to we want to render some sound so that you can hear the spaces. Then some new topics are audio augmented reality and virtual reality, sound in virtual reality. We are doing research and also teaching on how to do sound in virtual reality applications. So how you can have 3D sound in headphones. And this audio augmented reality is a special case where you have a special headphones where you have microphones also. So you can render the sound so that you hear the natural environment. And then with these microphones and special EQ, you actually have also like transparent headphones. So you hear everything, but then you have still headphones and you can add something. So that's like augmented reality. And then we are doing a lot of work in headphones and equalizers and these kind of things. Okay, our program is 2 years. Application period is open now and it closes 3rd of January. So you should apply almost immediately. There's the language of instruction is English, and all the courses are in English. So we are teaching everything in English, even though most of the teachers are Finnish, but then everything is in English. We have one professor who is coming from Germany and he's also teaching in English. The duration is 2 years. It requires full-time studies for 2 years, but everything is possible to do in 2 years. What else I can say? It's 120 credit points, and it's the school which is organizing that is a school of electrical engineering. But as I said, you can come from computer science, you can come from psychology, even physics or mathematics are good. I think the main thing which is the common to our students is that they are playing some instruments or singing in a choir or somehow are interested in sound. Maybe recording engineers also, because then you might need this kind of interest to sound to study acoustics and audio technology. And then from people who are coming from outside EU, the tuition fee is 15,000 euros a year for master studies. So in total, 30,000 years for 2 years. 20,000 euros, sorry. Okay, these are the facilities a little bit. What we have in our lab, this is the picture on the right, is brand new picture. It's an anechoic room, even though there are no wedges on the wall, which you usually see, but this is a new technology also that instead of wedges, there is a lot of foam, which is attenuating all the sound. And then we have there 40 loudspeakers in a 3D setup where we can do listening test and where we can test these 3D rendering algorithms. So that's in one anechoic room, and then we have a big anechoic room and small anechoic room for all kind of measurements. So anechoic room means that there are walls which are absorbing all the sound. So the sound is not reflecting back from anywhere. It's the same situation that if you go to an open field outside and the sound is not reflecting from anywhere. These are the special facilities that usually the acoustics labs have. Then we have a variable acoustics room, which means that there are panels on the wall that we can control how much they absorb sound. So the room actually can be quite reverberant or it can be quite dry. And that's also really good for testing different algorithms or doing some measurements. There is also 3 screens and about 40 loudspeakers in a 3D setup where you can also listen to spatial sound. Then we have 3 listening booths. These are for headphone listening, so they are isolated booths where you can do some studies with headphones. Then we have a standard listening room, which is in the small picture there, down there. That's a kind of a normal living room environment, but it's standardized how it should be constructed and so on. And there we have also multiple loudspeakers. And it's kind of, you can do whatever. You can listen to stereo, normal stereo, or even mono, but then you can have also like 5.1 or some other surround system, and then listen these things. Then we have small workshop for electronics, woodwork, and metalwork. We have one course where people are constructing a loudspeaker with, let's say, small parts, and then these workshops are used in this course. But it's also that they are also, the students can use them from some of their own projects, or you can make a special assignment constructing a loudspeaker or build some other device, maybe an instrument or something. Okay, then about the studies, the structure of the studies is that what we have there on the left side, that's in total 120 credits, as I said. But our major is this red block up there in the left up corner. Our major is something like 50 credits that you can do, or even actually, I think nowadays we have the major, all the mandatory courses is this kind of small major, which is from 40 to 45 credits. And then in connection to that, you can have a minor if you want. That can be on machine learning. It can be on construction, or some engineering related things, what you are interested in. And then, as you can see, that we have the elective studies. So now actually, when I see this is actually so that you should even look at when you have the big major, the upper part or the lower part. And then in our acoustics, it's probably the lower part, which is the correct one. So there's a major of 40 to 45 credits, then minor, which can be from some other field also. You can take business if you want for 20, 25 credits. Then master's thesis is always 30 credits. And then we have elective studies. So this is in purpose that we have actually quite a lot of freedom. So acoustics is only like 1/3 of your studies here. And then another third is the master's thesis, a little bit less than third. And then all the others are elective studies. And that's in purpose because acoustics is really a multidisciplinary field and you need something else to combine with. Is it business? Is it physics? Is it construction? Even maybe architecture a little bit, or some arts? It really depends on what you are interested in. And we try to keep it as open as we can, so that people can really select those things which they think are important for their career and what they are interested in. Okay, as I said, we have 4 professors in acoustics. First one is Ville Pulkki. He's running his team, which is called Communication Acoustics Research Group. At the moment, he's doing time frequency domain processing of spatial audio, and also higher order spherical harmonic input. So that means in practice that when you are recording something, you have microphone arrays where you have 32 microphones, or even more, 46 microphones, no, 64 microphones or something, and then how to process them optimally so that when you are listening them in a spatial sound setup, that the spatial sound is reproduced as authentically as you can. Then Ville is also applying machine learning for virtual reality sound. He has a small project on that. Then Ville is our expert in psychoacoustics. He's teaching a course which is called Communication Acoustics, which is psychoacoustics, so how humans perceive sound and different sound-related things. That's why Ville is also doing binaural auditory models. So auditory models are the models of our hearing system. To understand our hearing system better, we have a mathematical models which we can test that, okay, for some signals, how these models work, and then that way try to understand that, okay, is this corresponding to what people are hearing? And recently also Ville has started to study a little bit of underwater acoustic systems, also having multiple hydrophones. Hydrophones are microphones which are underwater, but then if you have a really big number of microphones, what kind of things you can do with several microphones. Okay, then Vesa Välimäki, he's leading his audio signal processing research team. At the moment, they are doing quite a lot of deep learning algorithms for audio effects. So, as I said, graphical equalizers, guitar amplifiers, what else? If you want to make a digital version of them, then deep learning algorithms, so machine learning has been also proven to be a really good tool to find correct parameters for these digital implementations. Then Vesa is our expert also in signal processing for loudspeakers, headphones, and virtual reality and augmented reality headsets. So all kind of equalizations that you need to have the correct sound. Then artificial reverberation, that's also like area of digital audio signal processing, and that's kind of traditional way of doing some reverberation algorithms and do some reverbs that people are using when they are mixing and mastering records. And then Vesa has been also doing some timescale modification of audio signals so that you can slow down, for example, the music or the speech, so that you are not changing the pitch. So, for example, if you want to listen an audiobook, you can listen it faster or slower, but still the pitch of the voice is exactly the same. And then recently there is an interesting project which is automatic tuning of the piano. So there is a robot which actually is tuning the piano, but then the robot can turn the knobs and kind of tune the piano, but there have to be a microphone and an algorithm which understand that is it now in correct tune or not. And Vesa is really doing this analysis part that is it in tune or not, and how much the robot should turn the knobs. Okay, my own research team is called Virtual Acoustics Research Team. We have a specialty of analyzing and measuring spatial impulse responses, meaning that when we are measuring impulse responses, so the responses of the rooms, for example, when we are using multiple microphones, how we can extract from there the information that where the reflections are coming, so the spatial information also, and then also how to oralize that. We are constructing some new 3D microphone arrays, doing some how to render sound in virtual reality applications, and then also doing this spatial analysis of room acoustics modeling results. Then we have a long tradition in studying room acoustics. At the moment, we are doing some studies on acoustics of chamber music halls, so small halls where, let's say, a string quartet is playing. And then also there is one project where we are looking at the room acoustics of cinemas and mixing studios. So how the cinema environment changed the sound and what would be the optimal acoustic treatment for a cinema. Then completely another thing is a new bio-based materials. I'm cooperating with one Finnish company which is making acoustic materials out of cellulose. Cellulose are wood fibers, so basically we are taking wood and doing all kind of things that has been traditionally done to make paper out of wood, but now we are doing absorption material, acoustic material which absorbs sound really effectively. They are really nice because they are wood basically, so they are really healthy. There is no problem for problems for indoor air and these kind of things. And then we are also doing hearing in noise and reverberation. So we try to help people in Helsinki University Hospital that how they can better understand hearing problems and how they can actually test hearing problems that people have. And then last but not least is our professor in practice, Sebastian Slecht, who just recently joined our team. He's coming from Germany. He has a specialty in sound in virtual reality, so binaural rendering, then also 6 degrees of freedom in virtual acoustics, which means that not only like rotating your head, but then you are moving in a virtual environment, how the soundscape should change so that you would perceive that it's kind of a real soundscape. And Sebastian has also worked on spatial artificial reverberation and then some model analysis and synthesis, so some methods how to create some sound also. Okay, so when you enter our program, there is 2 years of studies, maybe also involved in some of the studies will be involved in our research. So there is a good opportunity to be part of the research team at the same time when you are studying, maybe doing a special assignment or even doing a master's thesis in our team. It really depends case by case. But we are also working really closely to industry, both in Finland, but also worldwide. And then there is a lot of possibilities to do an internship. I have one student, PhD student now, who is doing an internship in the Facebook Reality Labs in Seattle. And then also master's thesis positions in industry in Finland. And then probably you can also go somewhere else. And at the moment we have projects together with Facebook Reality Labs, as I said, then Nokia and Huawei, which are both in Finland. It's the Huawei office in Finland, and Nokia is a Finnish company, as you probably know. Then we have a continuous research collaboration with Fraunhofer in Germany. And then Finnish companies like Genelec, who is making really good loudspeakers, and Musician, which is making a software, a learning software for learning to play instrument. So guitar or ukulele or something else. It's really fancy software that it's recording the sound and it's immediately telling you how well you played and then also teaching you in a game-like environment. So these are just an examples. Of course, there are other companies also. And then after your studies, what you can do. Of course, you can go. We have our master students and PhD students. Some of them stay in Finland, but people are also going abroad. And then where they are nowadays working. So here I listed just some companies where our alumni, so former students, even masters or PhD students, are working at the moment. They are in US, in Apple and Microsoft, and Dolby has an office in Stockholm, close to Finland. There are a couple of researchers, then Nokia, Huawei, and Skype, which are close by here. Then Musician, which I already talked. Remedies is a game company which is making computer games. And then many of our students go to consultant offices. Even in Finland, we have several offices. And then, but then one of my former students went to UK to work as an acoustic consultant. And then, of course, then we have also collaboration with, let's say, bigger industry, which means Wärtsilä, who is making huge diesel engines and power plants. They have a lot of vibration problems, which is related to sound also. And then Kone, which is making elevators, and Valtra, which is making tractors, and so on. So it's actually really wide scope of possible career opportunities and possible workplaces. There's one alumni story from Laura McLeod. So here's the link if you want to check that one. So Laura came from UK. She had a bachelor degree in Edinburgh, University of Edinburgh, and came to Finland for this master's program. Studied 2 years here, learned a lot. She was also really active in student union, is this kind of international student activities. He was going to Lapland, to northern part of Finland with them, and traveled around of Finland quite a lot. And then also now when she graduated, she did a master's thesis in my research team, and now she's back in UK working for a consultant office. But there is an interesting story if you want to read. Okay, something about Finland. So Finland is what we say, safe, relaxed, equal, organized society. So it's really good place to be. Some people say that the weather is not so good, but it's only a matter of equipment. If you have a good coat and something like this, and it's inside is always warm. Which is totally different than, for example, in Central Europe, where during the winters it might be cold, but here we have the central heating systems and everything. And then it's really easy to be in Finland, especially in the capital area. Everybody speaks English, even in the grocery store or bus drivers, everybody speaks English, so you can operate in English anywhere. You can try to learn Finnish also, which is recommended, but it's not necessary if you don't want it. Yes. So student life, I already described a little bit. There's the student union, which is a lot of different organizations and communities where you can find different activities. Then the housing, we have different housing systems. You can go to free market, rent a place, but then there is also like the reduced rents in student housing. So even at campus, or there are different spots around capital area where this kind of student house, so they are not so expensive, and then it's only students in these houses. And then the student healthcare is taken care of. So there is a Finnish student health service. So when you are a student, when you have a study right here, then you are in this student health service system, and then if you get ill or you broke your leg or something, you can go there for free. So this is just a reminder of the schedule. So the application period is open now, and then it closes early January, and the results will be published at the end of the March, and then the study starts in August, September. So we usually start earlier than in Central Europe. It's really in the beginning of September, even the last days of August. And then here are the addresses where you can send your applications. And if you have any questions, you can, of course, ask them now, or you can send the questions to this email address. And then some requirements. So you should have a degree in these various fields, bachelor degree in computer science, software engineering, communication engineering, electrical engineering, whatsoever. And then what we are requiring, it's mathematics. We are using quite a lot of MATLAB in our studies. So there is a lot of assignments in almost every course. There is some kind of assignment, because you learn best when you have to do something. And there people are using MATLAB or Python or some other scripting language to do these signal processing assignments. Good. Thanks for your attention. And I think now it's time for questions. Do we have any? Okay, we have the first question is there a minimum grade for my bachelor's degree?
Hi, I'm Emma. Hi, Eva Halonen. I'm the planning officer of the program. So we haven't really set a minimum grade for bachelor's degree. Well, actually, the students coming from the University of Applied Sciences, the minimum grade is 4, but otherwise, no.
Yeah, Applied Science, University of Applied Sciences is a Finnish system. But if you are coming from outside of Finland, we don't have any minimum grade. We are looking the papers as a compounder that, okay, what kind of studies you have, maybe a little bit of grades, but then also that what kind of other there is a motivation letter, so what motivates you to study acoustics and audio technology. And then by this way, we evaluate all the students. So they are going one by one. We are looking really carefully. But there is no minimum grade for that. So you can always apply. Okay, there is the other one is how strong does the mathematical background have to be? I would say that engineering level mathematics in bachelor would be required. So matrices, some integral equations, something like this, differential equations, these kind of things. There are some courses which are actually quite demanding, so you should have some mathematical background. So if you are starting on the high school level, that's not enough to do everything. Of course, you can learn everything here, but it's still good to have something. But if you have a bachelor degree in let's say, in any engineering related areas, then I think the mathematical background would be enough. Okay, the next one is when do students choose a topic and professor for the master's thesis? It's on the second year. So it's a 2-year program. In the first year, already in the first fall, so within 1 or 2 months, we interview all of our students. I probably do it myself. I have in the first period, there is also my course, and then Ville Pulkis one course, and then I interview each of you individually. And then we are already looking a little bit at what you are interested in, what would be the elective studies which would be really good for you. And then we are already kind of taking care that you are doing the right studies for your career and what you are interested in. but then mainly the professor and the master's thesis is selected in the second year. You can do it immediately, but probably you don't just know enough that what are the offerings. So the second year is usually, the second fall is usually a good time to do these kind of things. Okay, there's a question I would like to ask if the certificate of the English course at the high school level in Sweden, English 6 out of 8 or B, meets the English requirement. English 6 is a general entry requirement in Sweden for master's level.
No, I think it's best that you contact the admission services and make sure or ask this matter there. So you can just email admissions@aalto.fi and then ask straight. They will answer that question.
Yeah, but as I said, everything is in English. Even starting from the first course, the lectures are given in English. All the assignments are in English, and then you have to write also this kind of learning diaries, reports for the assignments, and these kind of things in English. So English skills are really required to understand these. But I think we have about the same requirement than in Sweden for master's level. But it would be really good to check from the admission services. Any other questions? We still have a quarter left for the reserved time, so there's plenty of time to answer the questions if there are any. But those who are happy and got all the answers, I really recommend to apply. And hopefully we will see next fall. Maybe we still wait a couple of minutes, but if there are no questions, then I think we will stop here. Okay, there is one question more, which is, could you provide some general examples master's thesis? Master's theses vary a lot. Some of them are done in a lab and some of them in the industry. If you go to industry, so usually the master's thesis is 6 months. The average time is 6 months. And it's in Finland, it's paid. There are some possibilities that you're not paid, but usually if you are hired by a company, you are hired for 6 months for quite low salary, but it's still, you got salary. And then it's the thesis is defined so that it's possible to do in 6 months. Usually there is some literature review, then some kind of experimental thing, doing a listening test, implementing a software package for something, or constructing some devices, and then somehow evaluating that. So measuring the device that you have constructed or something. If I take an example of Laura McLeod, whose story you can read from the link in the slides. Laura was doing a master's thesis in my team. She made a listening test of different concert halls where we rendered sounds in different levels, because we wanted to study that if you are listening on different levels, so if you are listening in really silently like the pianissimo playing, or you are listening fortissimo playing really loud, and then you are comparing different concert halls, do you get exactly the same order of the halls in all different dynamics? And then we work together because I have a lot of experience of doing the samples. So I actually did the samples for Laura, but Laura designed the test and she implemented the user interface, how to collect the answers from subjects. And then she ran all the listening tests, and then she wrote her master's thesis, so that there is some, we actually evaluated the halls by loudness and then on the envelopment of sound. And then her master's thesis is a literature study of loudness, how we hear loudness in different halls, and then how we hear this envelopment. So what are the earlier studies on these topics? And then she reported and analyzed the listening test data and reported that what was actually the result of our study. That's one example. There can be another one. There is one guy who is now doing in a company, which is a consultant company. He's measuring the noise, what you have in pipes, where you have water pipes, what kind of noise problems there might be, and how the water pipes actually should be constructed, so and how they should be attached to the structure of the whole house, so that you get the minimal noise from out of these. So he's actually developing a measurement method first, and then now they are measuring it and evaluating it, and then he is reporting then what kind of construction was the best. So these are all kind of things, but usually there is a literature part, and then there is an experimental part. But everything is defined and limited so that it should be possible to do it in 6 months, including the writing. It's the writing is 50. What we require is about 50 pages of text, including the references. It can be 60 to, let's say, 80 pages, but usually they are 50 to 80. Usually they are 50 to 60 pages long. Okay, maybe we are done. Thanks for your attention, and then we hope to get many applications.